The Aditya-L1 mission is India's first dedicated solar mission, named after the sun god, Aditya. It is aimed at studying the outermost layer of the sun, known as the solar corona, and its impact on the Earth's climate. The mission's primary goal is to enhance our understanding of the Sun-Earth connection and provide crucial insights into various solar phenomena. Key objectives and instruments of the Aditya-L1 mission include: studying the solar corona. Aditya-L1 will observe the sun's corona in various wavelengths to analyze its temperature, composition, and dynamics. This will help scientists better understand the mechanisms driving the corona's extreme temperatures and the origin of the solar wind. Measuring solar activity. The mission will monitor solar activity, including solar flares and coronal mass ejections, CMEs, which can impact space weather and affect Earth's technological infrastructure. Magnetic field measurements. Aditya-L1 will study the sun's magnetic field and its role in shaping the solar atmosphere, as well as how it influences space weather. Improved space weather prediction. Data from Aditya-L1 will contribute to better space weather predictions, which are important for satellite operations, communications, and power grid management. The Aditya-L1 mission is a significant step forward for India's space research efforts and will contribute to the global understanding of solar physics and its impact on Earth. It is part of the Indian Space Research Organization's (ISRO) ongoing efforts to explore and study our solar system and beyond. Please note that my knowledge is based on information available up to September 2021, and there may have been developments in the mission since. The Aditya-L1 mission is India's first dedicated solar mission, primarily focused on studying the sun and its impact on space weather and Earth's climate. Below, I provide a more detailed description of the mission, its objectives, instruments, and significance. Mission objectives. Study the solar corona. The primary objective of Aditya-L1 is to study the outermost layer of the sun, known as the solar corona. This region of the sun is of great interest to scientists because it is much hotter than the sun's surface, and the mechanisms responsible for this extreme temperature difference are not yet fully understood. Investigate solar activity. The mission aims to monitor and study various solar phenomena, including solar flares, coronal mass ejections, CMEs, and other solar activities that can have significant effects on space weather. Understand the Sun-Earth connection. Aditya-L1 will help scientists better understand the sun's influence on Earth's climate, space weather, and technological infrastructure. This understanding is crucial for predicting and mitigating the effects of solar storms on Earth. Key instruments and payload. The Aditya-L1 spacecraft is equipped with a set of advanced instruments designed to achieve its scientific objectives. Visible Emission Line Coronagraph (VELC). VELC is a telescope that will observe the solar corona in the visible and near ultraviolet wavelengths. It will provide detailed images of the corona and help in studying its temperature, density, and dynamics. Solar Ultraviolet Imaging Telescope (SUIT) is an ultraviolet imaging telescope that will capture high-resolution images of the sun's outermost layer. It will provide insights into the sun's magnetic fields and how they influence solar activity. Plasma Analyzer Package for Aditya PAPA is a suite of instruments designed to measure the composition, temperature, and speed of the solar wind and solar coronal mass ejections. This data will contribute to a better understanding of space weather. Aditya Solar Wind Particle Experiment (ASPEX) is another instrument focused on studying the solar wind's composition and properties. Magnetometer. The magnetometer on board will measure the strength and direction of the sun's magnetic field, helping scientists investigate its role in solar activity and space weather. Significance of the Aditya-L1 mission. The Aditya-L1 mission is significant for several reasons. Advancing solar physics. It will contribute to advancing our understanding of the sun's behavior, particularly the solar corona, which plays a crucial role in space weather phenomena. Space weather prediction. By studying solar activity and its effects on space weather, Aditya-L1 will improve our ability to predict and mitigate the impacts of solar storms on Earth's technological infrastructure, such as satellites, communication systems, and power grids. Global collaboration. The mission will provide valuable data that can be shared with the global scientific community, contributing to international efforts in solar and space physics research. Enhancing India's space capabilities. Aditya-L1 showcases India's growing capabilities in space science and technology, positioning the country as a significant player in solar research. The Aditya-L1 mission demonstrates India's commitment to exploring the Sun and its influence on our planet, making important contributions to both space science and our ability to manage space weather-related challenges on Earth. Please note that mission details and developments may have occurred since my knowledge cutoff date in September 2021.